This is a definition. The coefficient of the first term of a polynomial written in standard form is called the blank coefficient. Raise your hand if you think you know the answer. The coefficient on the first term of a polynomial written in standard form is called the what coefficient? The leading. She got it. I'll give you candy in a minute. All right. It's called the leading coefficient. Remember that was on the last test? Once a polynomial has been rewritten in standard form, which is where your exponents are biggest to smallest, the very first coefficient on it is the leading coefficient. Okay, we are on page 24. Go to page 24. I can't hear you. Okay, here we go. So last week we were learning how to graph linear equations. This week we're going to learn how to graph linear inequalities. The difference is the sign. Last week all of them were just equals. This week we have inequality symbols. The symbols are less than, greater than, less than or equal to, greater than or equal to. Okay, that's why they're called linear inequalities, because we have an inequality sign instead of an equal sign. We graph them the same way though. What is the slope? -1/5. Or couldn't you also have put the +1 and put the negative on the 5? You don't have to. I just prefer it. Okay, so if you choose to put the negative on the top, the directions for slope will be what? Down 1, right 5. If you choose to put the negative on the bottom, the directions will be right. But before you can even worry about that, we have to plot our y-intercept, which is 1. So on the y-axis, be quiet, you'll go to 1 and you'll plot your first point. From that point, you'll go down 1, right 5, or you could have gone up 1, left 5. Now, there's a difference today. Since we're not dealing with an equation, and since it's just a regular less than sign and there's no equal to bar, you're going to draw a dashed line. For your line, it's going to be dashed. This is the first day. Okay, look, this is just a less than symbol. Since there's no equal to bar under it, that means a dashed line. Kind of like when we were doing them on number lines, there would have just been an open circle. Because the points on the line are not solutions. Okay, let me say that again. Remember when we were doing number lines, if it didn't have an equal to bar, then you just did an open circle because that number wasn't an actual solution, right? Same thing with the lines. If there's no equal to bar, then you just do a dashed line showing that the numbers on the line are not the solutions. Okay? All right, now, in addition to the line, you also have to shade to show solutions. Okay, it says to shade everything less than the line. Well, if you go to your starting point and it says shade less than that, the starting point's at 1, right? Well, is a number like 0 or 2 less than 1? So you will shade that side of the line where the number less than is. So everything below that line gets shaded. You've got to pay attention. I don't have time to say things over and over because you're talking. You're shading the entire graph below the line. Shh, there's too much extra talking. Once you shade it, I'm going to do something, and I just want you to watch. I don't want you trying to write it down. Okay, so once you're finished shading, look up, and I'm going to show you something that I just want you to watch. And the shading doesn't have to be super neat, okay? Just scribble. All right. I want you to tell me a coordinate that falls in the shaded area. Any coordinate. -2. Okay, 0, 0. We'll go with 0, 0. It falls in there. Look, guys, doesn't the point 0, 0 fall in the shaded area? Well, in any coordinate, in the first number, your x value, and the second number is your y value. So what I'm going to do, remember, I don't want you to write this. I just want you to watch. I'm going to rewrite my linear inequality, but I'm going to replace this y and this x with the y and x value. So 0 is less than -1/5 times 0 plus 1. That becomes 0 is less than what? What will that become? No, right? 1. Because think about it. Anything times 0 is 0. 0 plus 1 is 1. Is that a true statement? Is 0 less than 1? Yes. Now, the reason that it's a true statement is because the point was in the shaded area. So what does that tell you about the shaded area?
Everything up in there is less than whatever that is.
Right. Every single point in the shaded area will make a true statement like that one did. So all of those are the solutions. There's no longer just one solution because we're not dealing with equals anymore. We're dealing with less than, which makes infinitely many solutions. What do I mean when I say infinitely many solutions? Right, like a lot more than one. You could sit here and pick points until you died. Okay, there's that many solutions. No, you're not required to do this. I'm just trying to show you that when I picked a point that fell in the shaded area, it made a true statement because any point in the shaded area is a solution. Now, the reason there's infinitely many is because think about it. Even though it doesn't show it on this paper, won't the y-axis continue to go down forever? And so will the x-axis. So the shading could technically go forever also, correct? So that's why there's infinitely many solutions, more solutions than you could ever try to plug in. Now I want you to pick me a point that's not in the shaded area. Okay, if I go right 2 up 2, that's definitely not in the shaded area. That's my x value, that's my y value, so I'm going to plug them in. In the y place I put a 2, and in the x place I put a 2. Now to see if it's a true statement, we need to simplify this side, so go ahead and type that in. You're supposed to do -1/5 times 2 plus 1. I mean, you don't have to write this. Just watch. Plus 1. Okay, what do you get? What do y'all get? Nobody's typed this in yet? Alpha y equals, we'll type in the fraction, 3/5. Now, if I were to write down 3/5, is it easy for y'all to tell if that's a true statement or not? What would make it easier? If this were a decimal. If this were a decimal, it'd make it easier to tell, right? So just use your calculator to turn that into a decimal. 0.6. Now that it's 0.6, is 2 less than 0.6? No. The reason it did not work and it did not make a true statement is because that point is not in the shaded area. The only points that will work are in the shaded area. Those are your solutions to the problem. Now we're going to pick a point on the line. Okay, what's a point that fell on the line? What? That's kind of iffy. Look, we only plotted 3 points. The rest of them are dashes. So let's pick one that we know for sure was a point. Negative 4, 3 is not. Negative 5, 2. Okay, well, we'll just go with this one. Negative 5, 2. The only 3 points that we know for sure on the line are this one, and this one, because those are the points we plotted when doing the slope. No, I want it on the line, but I don't want you picking in the dashed area because you might not pick correctly. Pick one of the points we plotted. There's way too much talking, guys, and your test is Friday on this whole packet. X and Y. So look, it was Y, which is 2, is less than negative 1/5 times X, which is negative 5, plus 1. That'll be 2 is less than, what does this become? Is that a true statement? No, 2 is not less than 2, they're equal. So even a point on the line did not work. So the only solutions to this problem fall in the shaded area. Not the points on the line, not the points on the other side. The solutions are all in the shaded area. Okay, now let's look at the second one. No. Okay, for number 2, what is the slope? Which means you're going to go what 2, up 2, right 5. What is the y-intercept? And that's what you plot first, so you'll put it on the y-axis at negative 4, and then from there up 2, right 5, or you could have gone down to left 5. Now, since this is just a regular less than sign with no equal to bar, that's kind of like an open circle on the number line, but in a line you put dashes. Just showing that it's not solid because there's no solutions on the line. Okay, now let's talk about where the shading would be. It says shade everything less than the line. So if you go to the line and it's at negative 4, what numbers are less than negative 4? So you shade that side of the line. We'll get there. We'll get there. She's talking about what will happen when there is an equal to bar. Kind of like on a number line you do a closed circle. So she's saying what will. Yep. Okay, so now look, I'm only going to do this one more time. You don't have to write it down. This is the last time I'm showing you mathematically why the shading area is the solution. Pick a point. No. Pick a point in the shaded area. Okay, 5, negative 6 will work. That's definitely in the shaded area. 5, negative 6. That's the x value, that's the y value. So in this inequality, y is less than 2/5 x minus 4. In the y place, we plug in what? And then in the x place, we plug in what? Now I want you to simplify the right side so that we'll know if negative 6 is less than it. Negative 2 is correct. Is negative 6 less than negative 2? Yes. Continue. Negative 6 is less than negative 2. That's a true statement. And the reason it's true is because our point was in the shaded area. That assures us that we shaded the correct place. Now let's pick a point not in the shaded area. Okay. 1 is the x value. Shh, be quiet. You're going to end up with a lot of homework at this pace. 2 is the y value. So in the y place, I put the 2. And in the x place, I put the 1. That becomes 2 is less than what? It's going to be a decimal, so type it in. You missed all last week. Or you missed a lot of that. How much did you miss last week, India? Negative 3.6. Is that a true statement? Is 2 less than that number? No. 2's not less than that. Okay, pay attention. No, I'm telling you to pay attention. Okay, now look. Shh. Man. Okay, so that's a false statement, and the reason it's false is because that point is not in the solution area. The shaded area are the solutions. That point doesn't fall in there. That's why it did not work. Now, I'm going to pick a point on the line for you. I'm going to pick the point right here on the line, which is 5, negative 2. Okay, the negative 2 is the y value, so it'll go first. And then the 5 is the x value. And now I'm going to simplify that and see if it makes a true statement. 2/5 times 5 is 2, and 2 minus 4 is negative 2. Is that a true statement? No. So what are you getting from this? The points in the shaded area work. The points not in the shaded area don't work. What about the points on the line? They don't work either. Okay, they're not solutions either. Only the points in the shaded area are working out and making true statements. Okay, now let's look at number 3. Y is greater than negative 1/2 x. What is the slope? Negative 1/2. So that means down 1, right 2. What is the y-intercept? So it's 0. If there's no visible number in the b place, that means it was plus 0, and they just chose not to write it. So we start out by plotting your first point at 0, and then from there we go. Correct. And you can do that a few times, or we could have gone right. Okay, we are still dealing with just a regular greater than sign. There's no equal to bar, which tells us to just put dashes, not a solid line, but dashes. And that's because there are no solutions on the line. If we picked a point on the line and plugged it in, it would not make a true statement. Okay, all the solutions are found in the shaded area, which for this case is greater than. Well, greater than would be these numbers above it, right? So you shade everything above it. Yeah, and then you're done. You don't have to do all that other work. I was just showing you that so that you understand why the shaded area are the solutions, because they're the ones that make a true statement. Yes, yes. The shading is very necessary because the shading shows you where all your answers are. Every point, say on the test they give you a line and then they give you 4 points and say which point is a solution. You would have to know to look at the graph and figure out which one of the 4 points would fall in the shaded area. Because the points in the shaded area are the solutions. They're the ones that if you plugged them in, X and Y, they would make true statements. What? Yes. Yeah. All right. Yes. If it's a greater than sign, you're going to shade above the line. If it's a less than sign, you shade below it. Okay, do you have a trouble seeing, like, knowing that that's greater and that's less? Okay, this is the only way I can remember. If you're looking at these signs, which one looks more like an L? This one. Think about it. If you tilt your head a little to the right, haven't I made an L? So that's how I remember that's less than, or how I remembered it as a kid. Okay, this is the less than sign. Okay, because look, if you turn sideways, we've made an L. Yeah, and if you turn 90 degrees, it's a V. So just turn 45. Okay. Number 4. Number 4. What is the slope? 4/3. So that's what 4? And what is the y-intercept? Okay, so we plot our first point at -3 on the y-axis. And then from there we go up 1, 2, 3, 4. We're already behind. And then up 1, 2, 3, 4, 1, 2, 3. Can I go down 4, left 3? No, I would run off by 1 unit, yeah. Okay, this is still just a regular greater than symbol. There's no equal to bar, so we're still just drawing a dashed line, which tells us what about solutions? There are no solutions on the line, right? The solutions are all found in the shaded area, which is greater than the line, which is above it, so this side of the line. Yep. All right, once you're done with that, turn to the next page. Oh, no, we got a lot more problems to do. 25. Y is greater than 2/3 x plus 2. What is the slope? And what is the y-intercept? This 2 tells us to go, and this 3 tells us to go. But before we do that, we plot our y-intercept at 2. And then go up 2, right 3, up 2, right 3. Or we could have gone down 2, left 3, down 2, left 3. It's still just a regular greater than symbol. There's no equal to bar, so you connect them with dashes, which shows that there are no solutions on the actual line. All the solutions will fall in the shaded area, which is above or below? Above. Numbers greater than, which are these numbers. All right, number 6. What is the slope? Yeah, you do. Right, isn't there an understood -1 in the in place? So to make it a rise over run, you always put it over +1. What is the y-intercept? -1. So from -1, we're going to go down 1, right 1. And you can do that multiple times. Or instead of going down and right, you could have gone up and left. Okay, now, this is the first time that our inequality has had an equal to bar, greater than or equal to. So for that reason, just like we did a closed circle on the number line, you are going to do a solid line. Now, pick a point on the solid line. -4, 3 will work. That's on the line. That's our x value. That's our y value. So, y is greater than or equal to -x minus 1. In the y place, I'm replacing it with 3. In the x place, look up here so you don't get confused, I'm replacing it with a -4. Well, that negative's already there, so it'll become a -4, which is a +4. And now that becomes 3. Is that a true statement? Yes, 3 is greater than or equal to 3 because they're equal. When you have a solid line, every point on the line works. All the points on the line are solutions in addition to the shaded area, which will be greater, so above it.
So that's why you got the line?
No, you don't have to do the stuff I'm doing on the side. You just need to graph it, draw the line, and shade it. No, I'm just doing all that for teaching purposes, showing you why the shaded area is the solutions, because those points are the ones that make true statements. Yes? 4. Number 7, what's the slope? There is a slope. 0. Think about it. Think about what this looked like originally. It was y is greater than or equal to 0x plus 0. And so they just chose not to write the slope at all since it was 0. But you have to write something. You can't just have an empty side, a blank side, so they put the b as 0. Because I'm showing that the reason they didn't write it is because it was 0. Your slope was 0, so they just chose not to write it at all. But you have to write something, or otherwise there would be no problem. So they wrote the y-intercept as 0. Okay, so we first start by plotting our y-intercept of 0. And then from there, what does this tell us to do? Just go right 1. So we're forming what kind of line? They're all straight. Horizontal. Is it going to be dashed or solid? Solid, because we have an equal to bar. And a solid line tells us what about solutions? All the points on the line are solutions. Every point on the, think about it. Every single point on that line has a y value of what? So any point we chose, if we plugged in the y value of 0 right here, doesn't that make a true statement? 0 is greater than or equal to 0. Now, in addition to the points on the line being solutions, so is the shaded area, which is greater. So that would be above. Okay, now we're going to skip ahead to some that are a little more difficult. So turn to page 27. Well, they're just not in y equals mx plus b form. Number 15 is, so we're going to skip it. Let's look at number 16. It's just a little bit more difficult because it's not ready to graph right away. But if you were paying attention last week, you know what to do. It was the end of the week. Okay, so look, we need it in slope-intercept form. So we begin by subtracting the x. Those cancel out, leaving 2y is less than 6 minus x, or we could just go ahead and do this. Zach, move back a seat. Okay, now we divide by 2. Those cancel, leaving y by itself, and I would go ahead and write in this 1 so that you'll know that's a negative 1/2 x, and then 6 over 2 is 3. So now we have rewritten this, and it looks like this. And now once it's in that form, we're able to easily identify the slope and y-intercept. What is the slope? Negative 1/2. What is the y-intercept? So you plot your y-intercept first at 3, and then the slope tells you to go down 1, right 2. So down 1, right 2, down 1, right 2, down 1, right 2. Or you could have gone, okay, is this going to be a dashed or a solid line? Dashed. There's no equal to bar. There's just a less than. So are there any solutions on the line? No. Less than, which will be below the line. So everything below the line is where all your solutions are. Not on the line, just below the line. Oh, you can tell me later. Number 17. Number 17. The first thing I need to do is take that to the side and rewrite it in slope-intercept form. So what do I do first? Minus x on both sides. Y is now less than or equal to negative 5 minus x, or you could go ahead and reverse that so that your mx is first and your b is second. So now that's ready to graph. What is the slope? Negative 1 over 1, because isn't that an understood 1? What is the y-intercept? Okay, so you start by plotting your y-intercept to negative 5, and then from there you'll go down 1, right 1. Or you could have gone up 1, left 1. Once we plot all the points that we can, or is it going to be a dashed or solid line? This time solid, and why is that? There's an equal to bar. And what does that mean solution-wise? All the points on the line are solutions because it's solid. In addition to points on the line being solutions, points where the line are solutions. Below, so this side. All right, number 18. X plus y is less than negative 2. What do I do first? And so y is now less than negative 2 minus x or negative x minus 2. So what is the slope? Right. What is the y-intercept? So I apply a point at negative 2, and from there I go, correct, down 1 and right 1. Or I could have gone up 1 and left 1. Am I going to do a dashed or a solid line? Dash, showing that the points on the line are not solutions to the inequality. They would make false statements. All the solutions are found less than the line, which would be below it, right? All right, number 19. The first thing we're going to do is subtract that 3x to the other side. I want to pause on this problem and do the next one and then come back to that one. Sorry, you'll see why in a minute. 2x plus y is greater than negative 4. What do I do first on this one? Okay, that becomes y is greater than negative 4 minus 2x, or we could go and reverse it so that mx is in the front and the b is after. And so now we're ready to graph that. What is the slope? What is the y-intercept? Okay, so I plot my y-intercept at negative 4, and then from there I go where? Okay, so down 2, right 1, or up 2, left 1. Okay, is it dashed or solid? Dashed. It looks kind of crooked, like I messed up. Okay, let's see. Up 2, left 1, up 2, left 1, up 2, left 1. That looks better. I think I had messed up a while ago. Okay, so draw a dashed line, and that shows us, since it's dashed, that there aren't solutions found on the line. All the solutions are greater than the line, which is above. Okay, now let's go back to number 19. Okay, so we started by subtracting the 3x. It'll cancel on this side, and now we have negative 4y is less than or equal to negative 4 minus 3x, or we could go ahead and just say negative 3x minus 4. Now what do we do? Right? And so now what do I have? Well, that will become a positive 1 at the end. This will become a positive 3/4. Okay, so now m equals 3 over 4, which is up 3, right 4. B equals 1. So I go up 1 and plot my y-intercept, and then I go up 1, 2, 3 over 1, 2, 3, 4, or I could have gone down 1, 2, 3, left 1, 2, 3, 4. Is it dashed or solid? Which tells us that all the points on the line are solutions. Okay, and then where do I shade? Okay, I want you to stop shading for a minute, and I want you to look up and pick a point in the shaded area. 2, 1, I heard that first. We'll go that. 2, 1. Okay, 2 is your x value, 1 is your y value. I'm going to plug that in. So 3 times x, and our x is 2, minus 4 times y, our y is 1, is less than or equal to negative 4. 6 minus 4 is 2. Is 2 less than or equal to negative 4? 2 is less than a negative number? No. So why did it not work? We picked a point in our shaded area. Why did it not work? No, it is. We just made a mistake. I let y'all make a mistake. It's a learning opportunity. It's a rule that I taught you when we were doing these on the number line. Thank you. He got it. You get candy at the end. Look, right here, we divided by a negative. So we should have flipped that sign, meaning we should have shaded over here. Okay? It's okay. Okay, so does everybody see, though, that if you don't shade correctly, your point will not work? Yeah. Okay, your homework is to finish any problem on pages 24 through 27 that we did not do together. I think that's about 8 problems. Finish all of them. Finish the 8 problems from 24 to 27. You can put it on the front. That we did. Just put it. Put it at the very bottom. Put it at the very bottom of your pink sheet on the other side. Okay, look, guys, on your pink sheet, just put it at the very bottom because this one's full. So turn the page over and put it at the bottom of that one. Pages 24 through 27, any that we did not do together. So tomorrow I'm going to check 24, 25, 26, 27. Every problem should be done. It's time to switch out.